Lesson 2-3, solving two-step equations. Essential question. How do you solve a two-step equation? All right, so we have x minus 5 over 2 equals 3. So this time, we've got to figure out what we need to circle. Because we always want to get rid of what's not circled first. So on ones like this, we're going to want to circle the x and then what's right next to it. So the minus 5. And then what we're going to get rid of first is whatever is below on our fraction. So on all of these ones today, we're going to get rid of what is on the bottom of our fraction. So to get rid of the 2, we can times both sides by 2. These cancel, and I'm left with the x minus 5 equals 3 times 2, which is 6. And then the opposite of minus 5 is adding 5 on both sides. And I end up with x equals 11. If I wanted to go back and check that, I could change the x to an 11. 11 minus 5 is 6. 6 divided by 2 is 3, which is correct. Then I've got 9 plus x over negative 5 equals negative 7. So I'll look for my variable and what's next to it. It's the 9. So if I want to get rid of the negative 5, times both sides by negative 5. So these cancel. Negative 7 times negative 5 is positive 35. Then to isolate the x, we got to get rid of the 9 by subtracting on both sides. X equals 26. Five minus x over 3 equals 7. So again, we'll circle what's next to the x, which is the 5. Now, one thing on this one, we don't want to have necessarily a negative variable. What will help you is if you have a negative x, that's the same thing as negative 1x. Put the 1 in there. It should help you with this one. So to get rid of the 3, we'll times both sides by 3. So 5 minus 1x equals 21. Then you're going to notice we still have a number then next to our x. So let's get rid of just the 5 first. So minus 5 on both sides. This one's a little bit trickier with that negative x. 21 minus 5 is 16. So then I'm just going to rewrite this over here because we don't want to have a negative variable. So we have to divide both sides by negative 1 so that we have just a positive x. So that one was a little bit trickier with that negative x in there. We had one extra step. All right, so 4 equals 2 minus 3x over 5. All right, so I've got my negative 3x, and then on this one I also have that 2 there. So really, I guess if you're looking at one where there's a number next to the x as well as another number on the top of your fraction, it may be easiest just to circle the negative 3 and the x and not include the 2. So let's get rid of that bottom number again first, the 5. So times both sides by 5. So 4 times 5 is 20. Those 5 canceled, so then we're left with the 2 minus 3x. Now if I keep this negative 3x circled, I should be able to see that now I've got to get rid of the 2. Well, I get rid of the 2 by subtracting because it's a positive 2. Now it's a much nicer problem where all I have to do is divide by negative 3. So x equals negative 6 is my answer, because 18 divided by negative 3 is negative 6. So those ones have quite a few steps that you have to write out in order to be able to solve them. Alright, now we're going to switch directions and do something completely different than what we've done in the rest of this lesson. We are going to try to find 3 consecutive integers with a sum of 57. So first of all, let's break down that sentence and figure out what they're really asking us. They want us to find 3 integers, so 3 numbers, positive, negative, 0, that are consecutive. Consecutive is our important word we need to know here. Consecutive means in a row. So I have to find 3 numbers. 1 number, 2 numbers, 3 numbers with a sum of 57. And that means if I'm seeing the word sum, that means that they all add up to 57. So what 3 numbers in a row add up to 57? Really on these ones I would take a calculator and I would do a guess and check. Keep plugging in 3 numbers in a row till you get 3 that make 57. So 15, 16, and 17, 21, 22, and 23, 18, 19, and 20, 13, 14, and 15. Those are all examples of 3 numbers in a row. What ends up working with this one is 18, 19, and 20. These are 3 numbers in a row where if you add them up, they make 57. Let's try another one. Find 3 consecutive odd integers. So that, again, they still have to be in a row, but they all have to be odd. So here's examples of odd numbers in a row. 1, 3, and 5. Or 5, 7, and 9. 11, 13, and 15. So they're all odd, but they're still in a row, as if you were counting odd counting rather than just counting regular numbers. So they still want us to find 3 odd integers, so I'm going to put my 3 lines for my 3 integers. I'm still figuring out the sum, so I'm still adding, but this time it has to total 117. So now pick 3 odds in a row and add them up and just keep doing that until you get to 117. On this one, 37, 39, and 41 work. Keep in mind they have to be odd and they have to be in a row. Alright, last one. Find 3 consecutive integers with a sum of negative 159. So I still need my 3 integers. This time they don't have to be odd, so I don't have to worry about what I worried about on the last one. But this time it has to make a negative 159. So that means all 3 of my integers are going to need to be negative, so when I total them, they make 159. And what works on this one is negative 52, negative 53, and negative 54. If you take your calculator and add all 3 of those up, they should make negative 159. Summary. To solve a 2-step equation,